Okay, this video is going to go through notes 14a, which is on adding, subtracting, multiplying matrices. Alright, here's some kind of background information on matrices. Hopefully you've at least seen them before, even if you haven't done any math with them. They are just another way to organize data. What I really need you to know is this highlighted information. Okay, a matrix is identified by its dimensions. So this has 2 rows and 2 columns, so it is a 2 by 2 matrix. And the dimension, okay, or the size of the matrix, determines what operations we can perform. So the first operation we're going to look at is addition. When you're adding two matrices, they have to have the exact same dimensions. So a 2 by 2 plus a 2 by 2, they're exactly the same, so we can add them. Alright, and when you add them, you're just going to add the numbers that are in the same spot. So like here I'm going to add 2 plus 1. Then I would add 4 plus 0. So if they're in the same spot in each matrix, you just add them together. Okay. If you have two matrices that are not the same size, so if you had, let's say, a 2 by 2 plus a 2 by 3, that would be undefined. Alright, they're not the same size, they can't be added together, so your answer that you would write is undefined. Then we have subtraction. Subtraction has the same rules, same process as addition, so they have to be the exact same size. And then you're just going to subtract the numbers that are in the same spot in each matrix. Alright, so with some examples here, why don't you pause and try these real quick and then come back and check your answers. Alright, here are the solutions to these problems. So again, we're just adding or subtracting the numbers that are in the same spot in each matrix. The next operation that we're going to look at is called scalar multiplication. So what we're doing here is we're multiplying a number, so in this case 4, times an entire matrix. And when we do this, I want you to think of it like the distributive property. So I'm just going to multiply the number that's outside, in this case 4, by every single number in the matrix. So 4 times 1, 4 times 2, 4 times 3, so forth and so on. So you're just multiplying the number times a matrix. That's called scalar multiplication. Then we're also going to multiply two matrices times each other, so a matrix times a matrix. When you do that, the size of the matrices matters. So the first matrix has to have the same number of columns as the second matrix has rows. Okay, and the easiest way to figure this out is to write out the dimensions. So matrix A, this matrix has 2 rows and 3 columns, so it's a 2 by 3. This matrix has 3 rows and 2 columns, so it's a 3 by 2. So if you write out the dimensions in the order they're being multiplied, the inside numbers have to be the same. Alright, so this is a 3, this is a 3, they match, so that means that I can multiply these matrices. If you ever write out the dimensions and you get different numbers on the inside, then they cannot be multiplied and you would say your answer is undefined. Okay, so your inside numbers tell you whether or not they can be multiplied. The outside numbers give you the dimensions of your answer. So a 2 by 3 matrix multiplied by a 3 by 2 matrix will give me a 2 by 2 matrix as the answer. Okay. So let's look at some examples with numbers. So here I have two matrices. First let's check and see if they can be multiplied. So this is a 2 by 2. And this is a 2 by 3. So they can be multiplied because 2 and 2 are the same number. And my answer is going to be a 2 by 3 matrix. So I'm going to go ahead and make blanks by that. So I'm going to have 2 rows and 3 columns. So that's going to be the size of my answer. When you multiply matrices, you multiply row by column. So I'm going to do the numbers in the first row, and I'm going to multiply them by the numbers in the first column, right, in the second matrix. So 1 times negative 3 gives me negative 3. 5 times 4 gives me 20. So I'm multiplying row by column. Okay, then I'm going to repeat that process for the rest of the columns. So I'm going to do row 1 times column 2. So 1 times 1 is 1, and 5 times negative 3 is negative 15. I'm going to do it again for the third column. So row 1 times column 3. 1 times negative 6 is negative 6. 5 times 2 is 10. So that gives us the first row. Then we're going to move down and repeat that for row 2. So I'm going to do the second row times the first column. 5 times negative 3 is negative 15. Negative 5 times 4 is negative 20. Okay. Then continuing on, I'm going to do row 2 times column 2. So 5 times 1 is 5. Negative 5 times negative 3 is 15. And then one last time, row 2 times column 3. 5 times negative 6 is negative 30. Negative 5 times 2 is negative 10. Then for my final answer, what I'm going to do is all of this addition or subtraction. So I'm just going to simplify. So negative 3 plus 20 is 17. 1 minus 15 is negative 14. Negative 6 plus 10 is 4. And then on the bottom, negative 15 minus 20 is negative 35. 5 plus 15 is 20. And negative 30 minus 10 is negative 40. So there is my answer, a 2 by 3 matrix, just like we got when we did the dimensions. Here's a second example problem that I want you to pause now and try, and then come back and check your answer. All right, there's the answer for that multiplication problem. Oops, let me make this a matrix. If you did not get that or need help or whatever, just come see me in class and we'll talk about how I got the answer to that problem. Then we have two just little tiny things to talk about. The first one is transposing a matrix. So what we're going to do here is switch the rows and columns. So ABC in matrix A was a row. Okay. In the transpose, we're going to make ABC a column. So instead of those numbers going across, they're going to go down. Okay, so you're just switching the rows and columns. And when you do that, watch, it also switches the dimensions. So this is a 2 by 3 matrix. It has 2 rows and 3 columns. This matrix is a 3 by 2. It has 3 rows and 2 columns. So we switched the dimensions, we switched where the numbers are located in the matrix. That's called the transpose. And then the last thing, super easy, the additive inverse. Okay, all you're doing here is changing the sign of every number. All right, so if it's positive, make it negative. If it's negative, make it positive. That's called the additive inverse. We're just changing the sign of every number in the matrix. And that is it for the first section on matrices.